Welcome everybody. In this video, we will learn about the projection of solids, and here we solve the problem of prism and pyramid. We will go directly to the problem, and the problem is draw the projection of a cube of sides 25 mm resting on HP on one of its corners with a solid diagonal perpendicular to the VP and parallel to the HP. Gist of the problem: a cube whose one side is 25 mm and AB is a diagonal. This diagonal AB is parallel to the horizontal plane and it is perpendicular to the vertical plane. Before starting this problem, we will try to understand the basic shape of cube and prism, because cube is a prism. So what is prism? Prism is a solid geometric figure whose two ends, that means base and top, are similar, equal and parallel to each other, and whose faces are parallelogram. And if we cut the cross section at any distance along the center line, we always get a similar and equal cross section. And the shape of base can be any kind of polygon, such as square, rectangle, pentagon, hexagon, etc. So cube is also a prism. Now this is the edges of a prism, and this is the corners, and this is called the faces of a prism. Let's start the problem. First of all, draw the XY line, which is the intersecting line between two planes. Now draw a perpendicular line with this XY line. Now take any random distance on your compass or divider and use this intersecting point as a center. Cut these two lines by draw an arc. Now join these 2 points by a line and then extend this line. As we take the same distance, so this angle must be 45 degree. Now take the 25 mm distance, which is the length of one side of the cube, on your divider or compass, and mark this length on a 45 degree aligned line. Now use this point as a center. Cut the vertical line taking same length. Again draw two arcs. Use the end point as a center of previous two lines. So we will get an intersecting point between two arcs, now joined by a line from point to point. Now name the points such as A, B, C, D, etc. Next, draw the projection line which is perpendicular to the XY line. Next, taking the same length, mark on the projection line which is height of cube. After that, join from point to point by a line. We will draw this front edge on the projection line coming from point V. Then we will give the names such as A dash, B dash, C dash, D dash for the front view. Now I am drawing the pictorial view of the cube. After that, we will give the name of the top plane. Earlier we gave the name of base plane ABCD. Here we see that if we look at top, the points of the top plane will merge with the same points of base plane. So we will give the name of the point 1, 2, 3, 4 for the top plane on the same point of top view. Now we will give the points name 1 dash, 2 dash, 3 dash, 4 dash at the upper sides of front view. Now We will join the point from A dash to 3 dash by a line, so that this A dash 3 dash line will be the solid diagonal of this cube. This is our true front view and true top view when the cube is resting on the HP without any inclination with the HP and VP. Here I draw the front view on another paper to clearly understand the inclination with horizontal plane. Here we can see that A dash 3 dash is the solid diagonal. Now I will parallel the solid diagonal with the XY line to show the parallel position with horizontal plane. And now you see that cube is resting by its corner point C on the HP. And this solid diagonal is for staying in a parallel position with the HP. The cube is automatically makes an angle with the HP. Now I will redraw the front view in this position. But a view, if I draw in this place, another view will be overlapping. So I will draw the front view by moving a little at any distance. Let's start the second step. First of all, draw a parallel line of the solid diagonal A dash C dash from the point C. Then draw the perpendicular line from the point 3 dash along with this parallel line. Again draw another perpendicular line along with the XY line from a suitable distance. Then take this distance and cut it on the perpendicular line by using your compass or divider. I named this point as O. So this distance is O3 dash. Now take this OC dash distance and cut it on the XY line from the point O. Now join this line. Draw a line from 3 dash point parallel to the XY line. Now take this A dash 3 dash distance and cut it on the parallel line. Now join from point to point by a line. Take the distance A dash C dash, draw an arc. Consider point 3 dash as a center. From the point A dash considered as a center, draw another arc of the length A dash 1 dash. Taking this intersecting point between two arcs, draw the rectangular part of front view. Now draw the rest of the front view in this way. After completing the drawing, give the name of each point. Now draw the projection line which is perpendicular along with the XY line. Now draw the projection line from previous top view which will be parallel to the XY line. Mark the intersecting point between two projection lines for the same point of front view and top view. Point B, point C and point D. Now I will join from point to point by line. Point 1 and then point 2, after that point 3 and point 4. Now join the points to point 1, 2, 3, 4 with line. Then join the points B2, A1, D4 as a height of the cube. There are some edges that we cannot see in this top view. So here we will use the hidden line. Hidden lines are drawn with dash line. In this way we finished our second step. On another piece of paper, I have drawn the top view to clearly understand the inclination with the vertical plane. Use the point C as a center. I will rotate the top view at an angle 90 degree along with this XY line. Now you see that the solid diagonal AC makes an angle of 90 degree with the vertical plane. So I will draw this top view by moving a little suitable distance in order not to overlap the two views. And finally we will draw the front view as the change of top view. First of all, draw a projection line from the point C or T which is parallel along with the XY line. To draw the rectangle made by projection line, consider point C as a midpoint. Compare with this figure, mark the midpoint C as the cube is resting on this point. Then draw the perpendicular projection line on both sides of point C. Again, compare with this figure, draw the graph of projection line and take the measurement by using your divider or compass. Again, compare with this figure, mark the resting point C. Then mark the other points around this point. Now draw the top view with the help of this reference figure. This is the final top view. Again, draw the projection line from this top view which is perpendicular along with the XY line. After that, draw the projection line from the previous front view which is parallel along with this XY line. Mark the intersecting point between two projection lines for the same point coming from front view and top view. In this way, mark the point B, C and D. Then join this point to get the shape by using a light line. After that, mark the point 1, 2, 3, 4 just like the point A. Draw the outline by join the end point. We will draw hidden line or dash line to show the hidden edges or part which are not visible from front. In this way, we get the final front view and top view of this cube. These problems have been drawn in AutoCAD for better perfection or better to understand. Second problem. A pentagonal prism is resting on a corner of its base on the ground with a longer edge, containing that a corner inclined at 45 degree to the HP and the vertical plane containing that edge and the axis inclined at 30 degree to the VP. Draw its projection, base 40 mm side, height is 65 mm long. Let's go to arrange the problem. As it is a pentagonal prism, so we will get pentagon at base and top. This is the corner of pentagon, and this is the shorter edge and longer edge, and this is the rectangular faces. At first it is rest on the HP and inclined at 45 degree to the HP and 30 degree to the VP. Let's start the problem. Draw the first of all XY line. Along with this XY line, draw a perpendicular line. As the prism is resting on the HP, so we will get the pentagon on the HP. Let's start to draw the pentagon. Set the 40 mm distance on your divider or compass. Leave some distance and take this measurement on this perpendicular line. Now we need to know the internal angle of a pentagon. Here is a formula to know the internal angle of any polygon, and the formula is 180 minus 360 degree by n. N is the number of sides. For pentagon it will be 5, and for hexagon 6, for octagon 8, etc. So we get the internal angle of a pentagon by using this formula is 108 degree. First of all, draw 108 degree angle. Then take the same measurement on this line by using compass. Then from the end point of this marking, draw another perpendicular projection line. Again, taking same length, cut on this perpendicular line. Join these 2 points by line. Take the collinear endpoints as a center. Draw 2 arcs of these 2 sides. Taking this intersecting point between 2 arcs, complete the drawing of pentagon. So here we see that no need to measure the all internal angle of pentagon. Just do one. Now with the help of this top view, we will draw the front view. Thus we have completed our first step. Now we will go to the second step. Step 2. Inclination with the horizontal plane. As the prism is make an angle 45 degree with the horizontal plane, so we need to draw an angle at 45 degree on the VP. Because we know that inclination with HP can be seen in the VP and vice versa. To make 45-degree angle, take any point as a center on the XY line. Make a semicircle with any random radius. Then draw the perpendicular line from this center. After that, draw two arcs, taking the end point as a center of diameter of this circle. Also, take the same radius. Again, draw two arcs of same radius. Take the end point of radius as a center of this circle. Join from center point to intersecting point between two arcs by a line and then extend it. So these two angles will be 45 degree to the XY line. Then draw the front view in this condition. Give the name of this center point A because we consider this point as a resting point by the corner of this pentagon. Now draw the front view. Now draw the perpendicular projection line along with this ground line. After that, draw the parallel projection line from previous top view along with this ground line. Mark the intersecting point between two projection lines for the same point coming from front view and top view. You have to imagine the three-dimensional view of prism in this condition. Here I draw the pictorial view of this prism to clearly understand our problem. With the help of this pictorial view, draw the hidden lines for the invisible edges. This is the third step where prism is inclined at 30 degree to the VP. First of all, I will match the point A with the point A of top view which have been drawn on another paper. Then rotate slightly to make an angle 30 degree with the VP. Draw the 30 degree angle along with the XY line and then draw the rectangle MNOP keeping the point A in the same straight line. Then draw the graph of projection line and after that mark the point. Complete the top view. Then draw the perpendicular projection line from the top view which is 90 degree along with the XY line. You should maintain proper gap. After that, draw the parallel projection line from previous front view. Mark the intersecting point between two projection lines. First of all, draw the outline. After that, given the hidden line for invisible edge. For better perfection, this problem has been drawn in AutoCAD software. Now let's do the problem of pyramid. A hexagonal pyramid, base 25 mm side and axis is 55 mm long, has one of its slant edges on the ground. A plane containing that edge and the axis is perpendicular to the horizontal plane and inclined at 45 degree to the vertical plane. Draw its projections when the apex is nearer the vertical plane than the base. Before we start the problem, we need to know about the shape of the pyramid. Pyramid is a conic solid with polygonal base, and in geometry, a pyramid is polyhedron formed by connecting a polygonal base and a point which is called apex. Each base edge and apex formed a triangle called lateral face. If we cut the cross section along with its axis, we see that the cross section will be gradually decreased. Now we will start our problem. We see here a hexagonal pyramid whose base is 25 mm and from apex to center its height is 55 mm. And this is called slant edge. It is resting by slant edge on the ground. Okay, figure number 2, and a plane containing that the edge and the axis is perpendicular to HP. And in this condition, the pyramid makes an angle 45 degree with the vertical plane. First, we will draw the hexagon, and we know the internal angle of hexagon is 120 degree. We get by applying this formula. For this, first we have drawn a parallel line of xy and then 60 degree angle, that is half of 120 degree. Next, we will cut a 25 distance on this aligned line. And next, from the end point, we will draw a perpendicular projection line. And then draw the parallel projection line, use the same point. Take same length, draw an arc on this perpendicular projection line and then join this. Take same length, cut on the parallel projection line. Again draw parallel projection line. Taking same length, draw two arcs from the end point of these two sides. Again join from point to point using this intersecting point between two arcs. So in this method we draw a hexagon by just drawing a 60 degree angle. Now we will draw the projection lines. As it is a pyramid, we can see the slant edges from the top. So the top view will be look like this. Now we will draw a center line. Taking 55 mm height on this center line, we will draw the front view of a pyramid when it is in resting condition on the HP. In this second step, to resting the pyramid on the ground by the slant edge O', D', we will rotate the front view and Collinear the slant edge O dash D dash with the ground line. So we will take this O dash D dash distance on the XY line with the help of compass or divider. Again draw another arc, take the radius A dash O dash and use the O dash as a center. Now take the distance A dash D dash and draw another arc, take D dash as a center. Now join these three intersecting points with the help of line. Thus we complete the drawing of front view when it is resting on the ground by one of its slant edges. Now we will draw the perpendicular projection line from the front view. Give the name of all points of front view. Mark the intersecting point between two projection lines. Join from point to point, complete the top view and draw the hidden line for the invisible edges. Now we will do the third step. Here we rotate the top view at an angle 45 degree with the vertical plane, just like this. So first of all we will draw the 45 degree angle with the XY line. Consider this line as a center line. We will draw the rectangle and then draw the graph of projection line. Next, finish the drawing of top view in this position. Now draw the perpendicular projection line from top view along with the XY line. Now draw the parallel projection line from previous front view. Mark the intersecting point between two projection lines. After that, join the point. Draw the hidden line for invisible edges. Thus we draw the final front view and top view. This problem has been drawn in AutoCAD software for better understand or better perfection. Let's we solve the another problem of pyramid, and the problem is a regular pentagonal pyramid with the sides of its base 30 mm and height 80 mm rests on an edge of the base. The base is tilted until its apex 50 mm above the level of the edge of the base on which it rests. Draw the projection of the pyramid when the edge on which it rests is parallel to the VP and the apex of the pyramid points towards VP. Now we will gist the problem. Here we can see a pentagonal pyramid. One of its sides of base is 30 mm and the height is 80 mm long. In the second case, apex is 50 mm from the ground. And finally, the edge of the base is parallel to the VP on which it rests. Let's start to draw the problem. As the pentagon is resting on one of its edge of the base, so we will draw a perpendicular line and then mark 30 mm distance on it, and then we'll draw one internal angle of the pentagon is 108 degree. Then we will draw the pentagon. Then we will give the name of 5 points of pentagon. To locate the center of pentagon, draw the line from corner to opposite midpoint of any edge. Mark this intersecting point for the center of pentagon. Mark this center point with the name O. Now use this center point, join all the corners of pentagon. Then draw the perpendicular projection line from this top view. Now use this center point, draw a center line. Cut 80 mm distance on this center line for the height of pentagon. Now draw the front view. Now the second step, first of all draw a perpendicular projection line along with the ground line. Mark 50 mm distance on this perpendicular line. Take O dash, 1 dash, 2 dash distance in your compass. Draw an arc taking endpoint of 50 mm as a center and cut it on the XY line. Draw another arc taking the radius with 4 dash, 1 dash, 2 dash. Again measure O dash, 4 dash and draw one more arc. Use O dash as a center. Write the proper name of this intersecting point and from point to point join by a line. Mark the other points by using compass or divider, taking the reference from previous front view and complete the drawing. Draw the perpendicular projection line from the front view. Again draw parallel projection line from previous top view. Mark the intersecting point between two projection lines. Join from point to point. You always draw the outline. You see here that the pyramid is resting by the edge 1 2, so from top this edge will not visible, so there will be hidden line. Now here we see that the pentagon is resting on the edge 1 2, which is perpendicular to the ground line XY. Next we will rotate this 1 2 edge to parallel with the ground line XY, just like in this condition. First of all, we will draw a perpendicular line. Then take the height of top view and then make the graph of projection line. In this way, we will draw the top view in this condition, taking measurement from previous top view. Now we will draw the perpendicular projection line. Then we will draw the parallel projection line from previous front view. After that, mark the intersecting point between two projection lines. Join the point and draw the outline first of all. And draw the hidden line for invisible edges. This is our final front view and top view.